Web applications bring a lot of problems to the table. If you want to find out more about the vulnerabilities, stay tuned.
You're watching IT Pro TV.
Well, I'm glad you could make it because we're going to be talking about web applications and some of the vulnerabilities that can crop up. I'm sure there's not many, but Daniel, let's just set the scene. Why are we actually talking about web applications and vulnerabilities? Like why? I don't know. Why do we care?
Yeah, that's a great question because, well, they're everywhere. That's what's up. If you've got an organization or part of an entity at all, you probably have a web app. Now that might just be a static web page of who we are and what we do, but more often than not nowadays, we're seeing fully fledged web applications, things that users can interact with. They can send information to and receive information from. And because of those functions, we might open ourselves up to a vulnerability or two. There's, as Justin alluded to, myriads of different types, and we'll probably cover throughout this series, if we haven't already, we will in the future, some of the things you'll see in those web applications. But I just want to call out a few things specifically right here in this episode so that we can be more abreast of the security threat surface.
So Daniel, I've been thinking web applications have come a long ways, as you've kind of put it, right? Sometimes it's just static pages, but even back in the day, you had things like CGI scripts that would dynamically create HTML. I say back in the day. I have also recently still worked on web applications that use CGI scripts using Python, Perl. These are totally secure, right? And we should continue to use them?
Amen to that being absolutely wrong. No, they are not completely secure. It's as with any application, it's really up to the implementation and the developer to be as secure as possible. But it is definitely one of the ways in which we can find insecurities. It's very common because it's an easy way to take user input, do some stuff that they'd like it to do, and then give that output back to them via a web browser. So it was extremely common. That's why Justin uses the terminology of back in the day. It was extremely common to do it that way. Now we have more sophisticated methodologies using it, but that doesn't mean we're not going to come across this. Actually, up until a few years ago, there was a very well-known exploit that was being used called shell shock that allowed me through a CGI vulnerability to pass command execution to the system that I was accessing, right? That shell shock allowed me to create things like reverse shells or run commands and do anything basically I wanted it to do, and it did it as the root user. So I had full, or whatever service account was running. So if it was running as root, you were totally done.
You should not do that in general. Just FYI.
This should
I'm
just
like,
become,
I'm scared.
if you don't burn that in your brain, don't use root. You say, well, Daniel, you're logged into Kali as root. Yeah, that's because I'm...
He's also not running a production web server.
Right. And I can burn that Kali instance to the ground and still be fine. So that's why, and as I think we might have mentioned before, they're moving away from that model because more people are using it as their standalone. But let's move on. What I've done is I've built a CGI script. It is vulnerable to command execution. Let's see how that works itself out. Come into the machine here. I have Firefox up and running. I have accessed my web server, which is over there. And there I'm seeing choose your tool. I can enter an IP address. I have this drop down. I can do ping, dig, ifconfig. Cool, and then I hit submit. When I hit submit, it takes that IP and it shovels it over to a Perl script. That Perl script slurps it in and says, all right, he wants ping, and here's the IP. Cool, I'm gonna run ping on that IP, bang. But what is it doing? It's doing a system operation. It's running a system command. When you find things like this from time to time, you'll be able to get command execution because it's just taking it in and running it. So let's show you what I mean. If I just run something like do 127.0.0.1, enter there's your IP, I want ping, I hit submit, the tool runs, there you go, right? It pinged, I see 64 bytes, it acts, it's great, cool tool, awesome. Let's go back. Let's refresh the page here. I think I need to hit enter. There we go. And I'll type in 127.0.0.1. But if you're familiar with Linux at all, you can chain commands together using special characters like a semicolon. And if I do ls-al, or let's do the easy one to see, cat etc password. I want ping. I hit submit. It does. What's that? Right? Not only did it run the ping command, but it also ran the cat command against the file etc password and returned that information to my web browser. That is not good. This is why we need to really take caution when we implement CGI in our web applications.
And there's two things that really play against you from this context. Number one, typically CGI scripts are dynamic programming languages, Perl, Python, PHP. Along with those come this weird thing of like just doing execs or system level execs, where you're doing evaluations arbitrarily. It's an incredibly powerful programming tool, but on the flip side, it's a horrible security concern. Secondly, because people are setting this up, it's sometimes developers. If you're not aware that you should change to a service account that has very restricted permissions, then these commands that are being evaluated by the programming language evaluate in the context of the user that's running the service. If the user is root, then they have full root access, and it's all fun and games. So those two things play against you in the context of CGI. You can do CGI fairly securely. It does take a little bit of work, just something to remember. Now, Daniel, CGI, it's come a long way, but websites have gotten a little more complicated.
They have.
We've started to get things like, I need to log in. I need to come back and go, yeah, this is where I started from. And one of those mechanisms was for doing that were cookies. Cookies definitely don't cause any security problems, right?
Never in a million years. Cookies are delicious and tasty. Oh, you mean website cookies?
Yeah.
Yeah, no, those cookies dangerous.
Oh.
All right, those cookies can have problems. And there's a couple that we're just going to call out right here. One is session hijacking. Is if I am able to access Justin's session cookie that says, hey, you're Justin. We know who you are. Here's a little something to make sure that the rest of the website knows who you are. Just forward that on every time that you make a request for anything from us. We'll know it was you, and we'll send it to you. Glad to be of help, right? This is how we keep track of things like preferences when you go to a website. Oh, I want my site to be in English. I'm in this area. I want that. I want this. And cookies can store all that stuff for us. It also can be very great for like what I was just talking about, maintaining that session. Who are you? I now know who you are. But if I'm able to grab that using something like cross-site scripting attack or any other vehicle, then I would be able to impersonate Justin using that cookie. You'll see this in PHP applications. A lot of times you see PHP sesh ID or session ID, something to that effect. Get a copy of that bad boy, and he'll think you are that person all day long because that's what authenticates you. Now, it's not the only game in town. JSON web tokens have become the de facto standard. Justin, you kind of do this a bit, so you're bread and butter.
Now, Daniel, I'm going to stop you right there. Bread and butter, that might be
stretched too far.
That might be overstretching it a little bit. Oversales, so to speak. I have used JOTs, and JOTs are pretty handy, but just like anything else, you have to use them securely. You have to use them appropriately, and doing so is sometimes difficult to do. Just like with the cookie thing, I'm handing it off a lot of times between a front end and a back end just to prove who I am after I've authenticated. If I can hijack that, then I can kind of just hand that off and pretend to be you. I can also do some modifications. So they're not great. If you do them correctly, they're not too bad, though.
Yeah, but that's the key phrase. Do them correctly. Now, if you're looking to play around with this a little bit, and I can show you some of the problems that you might run into with JSON Web Tokens, is there's something available called the Web Goat. Getting it installed is a bit of a bear, I will not lie. But once it's there, it gives you a lot of good things for you to test and play around with to try to learn more about security functionality, such as with this. All right, you'll notice I've got the Web Goat up, and there it is, right? Great, got to log in. You just got to create a login. I've already got one. Now, I was bringing this up while you were talking, just hope you don't mind. But once you're logged in, you want to see sessions. Should populate over here. And one of the issues that they have is JSON Web Tokens right there. I like how it's JWT tokens.
Yeah.
That seems redundant.
You also pronounce it JOT.
Yeah.
Yeah.
Weird.
There's a bunch of bad things about these.
Yeah, there is. And you'll have exercises within here. One of them is this JWT signing. You can learn a lot about how JOTs work and some of their insecurities by using this feature right here, or this tool. And what it does is it allows you to vote. It's got a voting system. And when you pass that information, what I'm going to do is I'm going to start Burp Suites. And what Burp Suite does is it is an interception proxy. Just in case you were unfamiliar, once I get that started, I should then be filtering all my requests for web traffic through that proxy. Close that, go to the proxy, make sure that it's on. And if I try to make any kind of like request, like I want to log in as Tom, should be able to go, and then like make a vote. I want to vote now. And you'll see that that raised up. Burp should, you know what? Helps if you turn the proxy settings on. And then I'll vote again. There we go. Now inside of there, you see this long string of craziness under the auspices of access token, right? And there it is. Huge, weird looking thing. It's just a base 64 encoded string of information that the application is going to use to allow you to do things or whatever, right? If I right click that and I send it to what's called the decoder, I can go to the decoder tab, and in there, I can decode as, and since we know it's base 64, you say, how do you know it's base 64? Justin, how do I know that's base 64?
Because it's always base 64 and just the set of characters. If you see numbers, uppercase, lowercase, equal signs, and a dot, base 64 is a pretty good guess.
So that's a pretty good starting point right there. Yeah. But I like how you put it. That's what JSON Web Tokens uses to encrypt this stuff, right? And then if I change this to text, I can move over, and you start to see some real information in here, like what algorithm is being used and whether or not I'm an admin. You see this admin equals false, and what user I'm using. Well, guess what? I can modify this, go in here, change this algorithm to none, and then change admin to true. This other bit over here is what's called the signature. It's a broken up thing. There's actually three parts to a JSON Web Token. You have the header, you have the payload, and you have the signature. And what's cool is they take the header and the payload and they run it through an algorithm, which is HS512 in this case, and they digitally sign it with that. And they just add that to the end. And base 64 encode it. You're good to go. You've got yourself a JSON Web Token. Glory be, it's good times. But if I change this to null, make those modifications, and just wipe the signature off, it'll go, okay, because the signature says that it's null and there's no checks on the other side to make any difference. That would take some time, so we're just gonna kind of like, I just wanted to show you what's going on underneath the hood. We're not gonna actually do that, but I could do it. I have done it, and I highly recommend you play around with WebGoat to get more hands-on experience with that. It's a lot of good fun, but that's what's going on, and if I'm able to do that, I'm bypassing every bit of security that they've enabled, and I'll be able to do anything I want as an administrator. So that's why tokens, cookies, and things could get you in the weeds, and you got to be aware of that.
I want to point out a couple of issues for this being implemented. I should never put roles or anything like that in a JSON Web Token. I should maybe have an identifier, and I immediately verify with some kind of secondary check on the back end that I have control over as the developer.
Yeah.
Number two.
Number two.
The removing of signature and modifying those type things. There are a lot of times libraries have a way to enforce, I need to verify based on a signature, otherwise I will not decode the token, and it will fail. It means as a developer, I have to handle that error if it occurs, but it keeps people from doing exactly what you do. So if you're on the other side of it, keep that in mind.
That's right.
Now, Daniel, we're passing this information back and forth, and hopefully there's nothing private there, but sometimes in web applications, we need to send over maybe some personally identifiable information or the such. That usually requires an encrypted connection, which we assume always works, but does it always work?
Doesn't always work. Sometimes you run into a little bit of problems, and that's when new versions of those encryptions will come out. SSL is a prime example of that. When we work inside of web applications, if you've been at this business for any length of time, you're probably very familiar with SSLs. It's when you go to a website and it's got the little lock up there, or the address bar turns green, let you know this is a secure site. It's using HTTPS suite, right? Which is sweet. It is good. What version are you using? Because older versions have issues, right? We saw a lot of this with the crime or the breach attacks that occurred, that people were able to break the encryption and look at sensitive information. You also have Heartbleed, which was a huge vulnerability, which again leaked sensitive information through a string of attacks. You just have to run one exploit, and it could look at actual information on that local system, on a remote system, unauthorized, right? And Heartbleed is running. I think I do have a Heartbleed thing here. Yeah, so I've got this Heartbleed .py instance right here, so I can Python Heartbleed .py, and I think it'll probably kick me out of error, so I can get it. So it needs the port that it's listening on, which is 8443 by default. All right, and I probably need the actual server that it's going for. So I'll give it the 10.10.10.201 if I'm not mistaken for this one. And then does it need -p? I'll give it anyway. 8443. Let's see what it does. And you'll see that this came back, warning, this server returned more data than it should. This server is vulnerable. So I just found an exploit online. It exploits the fact that this server is running an insecure version of SSL. And if I scroll up through all this, which is like, oh my goodness, it's a lot of zeros. Yeah, it's kind of hammering the machine, but you'll see here, well, I might have to have logged in to get any real information. Oh no, there we go. Hey, look, what's that?
Oops.
That's a session ID. Guess what I can do with that now? I can log in with that, add that as my cookie, and it thinks I'm whatever person that is.
And there's an insecure request using password in plain text.
Oh yeah, right
yeah,
there.
password equals.
Log in. So you see that it's leaking that sensitive information because of that. We want to make sure that we're using the latest and greatest in encryption technologies when it comes to our web communications. So make sure you're using TLS version 1.3 is the latest one that's out right now. Again, you got to stay on top of those.
I got to look it up.
So always verify. Yeah, it's a good way to get yourself in the weeds. If you can implement a tighter security algorithm, that's what you want to go with. Justin, I think that's a good demo for us today. Kind of get the idea that if we don't do web apps right, you could land yourself in hot water, either through tokens or CGI, or even with the encryption algorithm that we're using.
I think this is a pretty good overview. Web applications usually have crazy large attack surfaces, so don't think this is the end-all be-all of those. But you know what? I think that's the end-all be-all for this episode. So we're going to go ahead and get out of here. So signing off for IT Pro TV, I've been your host, Justin Dennison.
I'm Daniel Lowry.
And we'll see you next time.
Thank you for watching IT Pro TV.